Hi students, I am Rihanna here from SNIT Adur. Here we are studying the subject Civil Engineering Project Management for 8th semester Civil Engineering as per APJ KTU syllabus. And as a part of revision, I am discussing the module 1, which is Construction Project Management. And in this module, we have already covered the basic portions, the introduction for construction project management. You have studied about work breakdown structure, construction planning and scheduling, and now we are dealing with the various methods of scheduling. In this portion, we have already covered the bar charts, milestone charts, and the basics for network diagrams. And today, we are going to discuss about the network analysis technique used for scheduling purpose. One of the most important network analysis technique is critical path method. So today we are going to discuss about this particular network analysis critical path method. Critical path method. The critical path method, commonly abbreviated as CPM, was discovered independently by DuPont and Spray-Rand Corporation in 1957. For the applications to industrial situations like construction, manufacturing, maintenance, etc. CPM aims at the determination of the time to complete a project and the important activities on which a manager shall focus attention. The CPM networks are generally used for repetitive type projects or for these projects for which fairly accurate estimate of time for completion of each activity can be made. The CPM networks are often referred to as activity-oriented diagrams. The activities are represented by arrows and the sequence in which the activities are performed is shown by the sequence of arrows. Activity times in critical path method or CPM. First one, early start time, which is represented as ES or EST. The earliest possible time at which an activity can be started is termed as early start time. The second one is early finish time, which is represented as EF or EFT. The earliest possible time at which an activity can be completed is termed as early finish time. The third one is late start time, which is represented as LS or LST. The latest possible time at which an activity can be started without delaying the project can be termed as late start time. And the next one is late finish time, which is represented as LF or LFT. The latest possible time at which an activity can be started without delaying the project can be termed as late finish time. So, these four times are very important in case of critical path method. First of all, you have to study what is this early start time, what is early finish time, late start time and late finish time. Then only you can do the network analysis properly. So the activity times in CPM include early start time, early finish time, late start time and late finish time. And the earliest occurrence time, which is represented as TE. The time at which an event may occur as early as possible is termed as an earliest occurrence time. And the latest occurrence time, or which is represented as TL. The time at which an event may occur as early as possible without delaying the overall completion time of the project is termed as latest occurrence time. Now, what is critical activity and critical path? Critical activity, it is an activity that if delayed will hold up the scheduled completion of a project. And the critical path is the sequence of critical activities that forms a continuous path from the start of a project to its completion. The critical path generally possesses the maximum duration. The duration of the critical path represents the minimum time required to complete a project. Next is the stages in determining critical path. The first step is specify the individual activities. Second step, determine the sequence of the activities. Third step, draw the network diagram. Fourth step, estimate the activity completion time. Fifth step, identify the critical path. And sixth step, update the CPM diagram. So there are 6 stages or 6 steps are involved in determining the critical path of a particular network, which involves first one, specify the individual activities. Determine the sequence of the activities. Third one, draw the network diagram. Fourth one, estimate the activity completion time. Fifth one, identify the critical path. And sixth one, update the critical path method diagram. Next is an important term in connection with this critical path method is slacks or floats. Now we have to study the different types of slacks or floats. The first one is total slack or total float. It is the extra time that could be made available to an activity, assuming that it has started at its earliest without delaying the whole project time. It is calculated as total slack or total float TF or TS is equal to LF minus ES plus D, where LF is the latest finish time, ES is the earliest start time, and D is the duration for the particular activity. The second one is free slack or free float. The extra time that could be made available to an activity, assuming it has started at its earliest without preventing beginning at the earliest any subsequent activity, that is not just the final time as with total slack, which is obtained as free slack is equal to earliest finish time minus the sum of earliest start time and the duration. And the third one is the independent slack or independent float. The extra time that could be made available to an activity, assuming that it has started at its latest without preventing beginning at the earliest any subsequent activity, which is obtained as independent slack is equal to early finish time minus the sum of late start time and the duration. And while analyzing the networks, it is very important in the two calculations, that is the forward pass computations and the backward pass computations. Now we have to study the procedure for forward pass computations. The procedure includes the first step is begin from the start event and move towards the end event. In the second step, put TE is equal to 0 for the start event. And in step 3, go to the next event if there is an incoming activity for the event 2. Add, calculate TE of previous event and activity time. And in the fourth step, repeat the same procedure for next step also. And the procedure for backward pass computations involves the first step, begin from end event and move towards the start event. Assume that the direction of arrows is reversed. And in step 2, latest time TL for the last event is the earliest time. So T is of the last event. And in step 3, go to the next event. If there is an incoming activity, subtract the value of TL of the previous event from the activity duration time. The arrived value is TL for that particular event. If there are more than one incoming activities, take the minimum T value. Always take the minimum TE value if there are more than one incoming activities. And in step 4, repeat the same procedure from step 2 till the start event. And now here I am fixing an example. Draw an activity on Arrow network and evaluate the network parameters using forward pass and backward pass. And the data is here. The activity, the precedence relationship and the duration in days is given. And with this data, here I have drawn the network diagram, which is an AO diagram. Now, the forward pass calculation for this particular activity, it is calculated as the earliest start. Forward pass calculation always includes the calculation of earliest start time and earliest finish time. The earliest start time and earliest finish time for the various activities are obtained as this. And in the next step, we have to move for backward pass calculation. The backward pass calculation includes the computation of the latest start time and latest finish time. Here it is obtained like this. Okay, hoping that you have understood the portion critical path method. It is one of the most important method used for network analysis. Study it well, work out more problems. Okay, thank you. Stay safe.